collection layer that is comprises of the LSM air electrode. And with this functionalization, we have got 2 amps per centimeter square current density at an voltage of 0.7 at and an operational temperature of 800 degrees centigrade in the fuel cell mode of operation. Now, the major drawbacks of this air electrode in the solid oxide cell mode of operation is their confined triple phase boundary, where the diffusion occurs only through the electrode surface or to the electrolyte surface, and thus the delamination of the air electrode layer took place due to the excess partial pressure of oxygen at the electrode-electrolyte interface, and thus reduces the performance in the FC mode and also in the EC mode of operation. In the FC mode, we have got 0.5 amps per centimeter square current density, and in the EC mode, we have got 0.55 amps per centimeter square current density with respect to the hydrogen and steam ratio 1:1. To combat such problems, we have to tailor the interface of the air electrode and electrolyte, and for this reason we have applied the gadolinium doped Syria based interlayer and its conjugate buffer layer with the mixed ionic and electronic conducting air electrode layer, and after that the mixed conducting air electrode current correction layer is applied on the top. For this gradation, for such gradation, the diffusion occurs through both the surface and bulk path, and also it helps to suppress the excess partial pressure of oxygen at the interface. The system we have studied are the barium, strontium, cobalt, iron, oxygen based system, where the X varies from 0.2 to 0.6 and Y is fixed at 0.8. The compositions we have studied are tabulated here. Here the scheme of the synthesis of these batches. From the X-ray diffraction analysis, we have obtained that the cubic phase is stable up to BACF 6482 composition, that is barium with 0.6 mole% as shown in this phase map. And when we increase the barium content from the 0.6 mole%, we have observed that the hexagonal phase and some mixed phases appear. Also from the phase map, it is clear that the composition close to the phase transition zone, that is 0.6 mole% barium, have the high ability for the lattice oxygen exchange and thus high performance air electrode for the solid oxide cell. Now we have optimized the BACF and its lanthanum conjugated system by the iodometric titration, where oxygen non-stoichiometry of 0.36 and 0.22 is obtained with barium is to strontium or lanthanum is to strontium ratio at 1.5. From the XPS survey spectrum analysis for these optimized batches, also we have observed that the formation of the CO-CO dot lattice is predominant for the BACF 6482 system, and thus aids the formation of the oxygen vacancy and molecular oxygen, and thus this composition is effective, may be effective for the oxygen evolution reaction. And in case of lanthanum conjugated system, we have found that the formation of CO-CO prime is more predominant. To exploit both the property of the optimized batches, we have synthesized the LSCF BACF based hetero interface, where the formation of the hetero interface is confirmed from the shifting of the 2 theta from the X-ray diffraction analysis, and also substantiated from the Raman spectroscopic analysis by the shifting of the Raman peak in the hetero interface material compared to the its pristine phases. Also in the transmission electron microscopic analysis, we have observed that both LSCF and BACF 6482 phases are present, and the highly ordered crystal lattice strain may be responsible for the high electrocatalytic redox reaction. Here I have shown the scheme for the cell fabrication. This is for the asymmetric cell fabrication and this is for the single cell fabrication. For the asymmetric cell fabrication, we have applied platinum and MIC air electrode of choice on the GDC based pellet, and for the single cell fabrication, subsequent layer of GDC based interlayer, buffer layer and MIEC air electrode layer was applied onto the nickel YSZ half cell. Coming to the electrochemical performance, for the amperometric study, we have observed that the threshold voltage for O2 minus ion pumping is at 0.8 volt under both the anodic and cathodic potential for all the system, and we obtained the lower degradation in current of approximately 0.015 for the heterointerface material, and for the LSCF the lower degradation is, in current is obtained for the cathodic potential, and also from the EIS spectroscopy we have observed that no such change, no significant change is obtained in the interfacial polarization after 200 hours of constant operation.
Let's conclude in 1 minute.
Okay, sir. And finally, we perform the electrochemical performance using the single cell configuration, where we have observed that the 2.36 amps per centimeter square current density is obtained for the heterointerface material, and in the reversible mode of operation, hydrogen generation flux of in the range of 0.2 to 0.23 normal liter per hour per centimeter square is obtained for all three composition. And we have also observed that the humidity intake capacity for the heterointerface material is quite high and can be augmented up to 80%, which can decreases the hydrogen content in the feed of hydrogen and steam mixture, which also increases the turn down ratio for the electrolyzer. Here are my major conclusions, which I have already stated before. Here are the list of my publications. Thank you all.
Thank you, Sarashri. So since I told that we are lacking behind the time, so 1 or 2 maximum questions, please. There.
Yeah, am I audible?
Yes, sir.
Okay. So it's a very nice presentation.
Thank you,
I have
sir.
a very small query, that is, this LSCF, BSCF, these materials are very old materials. What is so novel about these materials, number one? Number two is, so you are talking about these mixed conducting materials, but the equations you have shown in your slides, these Kroger-Vink notations, so all are showing this oxygen vacancy. So if you can throw some light, where from you are getting this electronic conduction? That's why, otherwise it will not become a mixed conducting material, right?
Yes, yes, yes.
Okay, thank you.
Actually, sir, for the second of your second question, the electronic conductivity of such material arises from the charge compensation mechanism, that is the formation of the CO-CO dot lattice or the CO-CO prime negative lattice. Here are coming from the electronic and for your first question, sir, my novelty is the functionalization of this material by applying the gradation layer using the gadolinium doped Syria based interlayer and with the buffer layer, and then the final MIEC air electrode layer, and also the novelty in the hetero interface material, which I have just recently started working on it. No, sir. Material, material is not. No. Yes.
Any more questions?
So, any more questions? So, since there is no questions, thank you so much once again.
Thank you, sir.
So, I'll ask, invite next speaker, Mr. Sultan Khan. He will be speaking on explanatory study on improvement of thermomechanical properties of phosphate laser glass. So, Sultan, I will remind you in 8 minutes.
Yes,
So
sir, I
finish
will
in
try.
8 minutes. Try to finish, so that you will get a time benefit.
Good afternoon, everyone. Today I will be presenting a topic on exploratory study on improvement of thermomechanical properties of laser phosphate glasses. So I will start with a report from Czech National R&D Center. They have developed some particular beam line for different application, but their energy power scale is limited to 100 watt to 1 kilowatt. And the application are mostly related to the secondary wave generation, micro machining and biomedical application. But if you want to increase the power scale, so what will be the strategies? So first of all, to increase the average power, the pulse repetition rate should be higher, and for this purpose, the emission and absorption bandwidth should be larger. But when the pulse repetition rate is more, so the gain medium or active medium will experience frequent thermal shock. So some good thermal management system should be employed in that system. And in another way, if we able to select such a rare earth element that has a low quantum defect, so it will generate less heat. So what are the active medium? To see, we will look at the configuration of a solid state laser. It is consisted mainly 3 parts. First one is the pump source, and we will be considering here only optical pumping process. Second one is, and the most important one is the active medium. It is a combination of the rare earth active ion for laser active ion and as well as the host material. And third one is the optical cavity. It is nothing but the setup of some specified optics. So here I have depicted the schematic of that solid state laser device. And because of this type of configuration, it is very compact and it can deliver better beam quality. So what are the scope for solid state laser? So we may go up to the megajoule scale or at the same time terawatt class high average power laser with some or bigger diameter of laser beam. So what are the challenges whenever we are thinking to scale up the power? So main challenges is the induced or generated heat that will experience the gain medium. So because of this heating of the gain medium, it will show the thermal lensing effect. That's why the energy extraction efficiency will be reduced, and at the same time the beam quality also deteriorated. And because of this thermal lensing effect, the higher repetition rate will be also limited. But in an worst cases, the gain medium will also break. And in another way, and people are now interested to generate high average power at cryogenic temperature, because at cryogenic temperature, the bandwidth of the emission band, particularly for the ytterbium ion, is more, so we can easily get higher repetition rate. But at the same time, due to the heating of that gain medium, the absorption and emission cross section are getting reduced. So here also thermal management playing the main role. Some research group has developed some laser device configuration in such a way that it can itself reduce the thermal energy which the gain medium will experience. Here they have placed the cooling system such a way that the axial heat flow will be the heat dissipation will be through the axial mode, and that's why the surface to volume DC will be more. And by this arrangement, they are experiencing the retroreflection technique, so the pump threshold will be reduced. Now, if we think about the solid state laser, so what will be the effective host material? So in solid state, there are 2 types of material are there. One is glass and another one is crystal. So if we think about the high average power laser, so rare earth ion solubility will be more, but because of the absence of periodicity, the glass can have some more rare earth ion solubility. At the same time, so if we thinking about the high average power, so the repetition rate should be more. So that's why the bandwidth should have more, band will be wider. At the same time, the optical homogeneity is required. but which all this property possess the glasses, but they are lacking in terms of thermomechanical properties. But as we all know that glass is a non-stoichiometric material, so we can easily manipulate this property by the composition or modification. So there are so many glass systems, but we will select one best glass system that will serve our purpose. So if we look at the properties of silicate system, they are thermomechanically very improved, but limitation is that because of their tetrahedral structure, so rare earth ion solubility is limited, and they demand high melting temperature. That's why to get optical homogeneity is very difficult, and there should be a platinum inclusion from the melting crucible. But in comparison to that silicate system, if we look at the metaphosphate system, they can able to have more ion concentration because of their chain-like structure, metaphosphate structure. And compared to the silicate system, the metaphosphate demand low melting temperature, so we can easily get optical homogeneity. At the same time, stimulate an emission, and fluorescence lifetime is also enhanced in the metaphosphate system. But the limitation for the metaphosphate system is that the thermomechanical properties are poor, and chemically they are not stable. So what are the important properties we should consider for improving the thermomechanical properties? This is a figure of merit parameter. RS is a thermal shock resistance. So by this equation, K is the thermal conductivity and KIC is the fracture toughness. And E is the Young's modulus, alpha is the thermal expansion coefficient. So if we can increase the thermal conductivity and fracture toughness, at the same time if the thermal expansion coefficient can be reduced, so it will give the more thermal shock resistant, and it will improve the thermomechanical properties. At the same time, another important property is the thermo-optical properties. Here delta is the thermal coefficient of optical path length. So normally, ideally it should be 0, and if it is 0, so that system will call athermal system. If you look at the, sorry.
Sultan, conclude in 1 minute.
Yes, sir. 1 minute. So if we look at that term, it is always a positive term because n is more than 1. So for getting 0 or negative value, so dNdt must be negative. So from the literature survey, we have found that barium phosphate system is very good in terms of high average power laser, and inclusion of alumina, it will also improve this properties. But at the same time, some researchers have shown the positive effect of silica to this particular system. It will improve chemical durability, thermal conductivity, thermal expansion, and fracture toughness will also be improved. So at the same time, selection of dopant ion is as important as matrix because of this particular energy band structure of ytterbium. Sir, just 1 minute. So it will, the energy gap between this ground state and the higher state is more, so multiphonal relaxation rate is very less, and because of this particular characteristics, we are getting this much of advantages. So we have selected the ytterbium as a laser active ion. So we have formulated 2 compositions. One is within the range of commercial phosphate gases, and another was out of this composition range. Here we have purposefully maintained the high alumina percentage, and the conventional melt quench technique was employed to prepare the glasses. This type of characterization we have done to estimate and comparative study of the required properties. So from the extractive pattern, we are not finding any crystalline peak, so it shows the X-ray amorphous nature of the prepared glasses. And from the FTR spectra, we have analyzed the glass molecular structure. So by critical observation, we have come to this conclusion that metaphosphate chain length is gradually reducing by the formation of chain terminator, And series B glass will show the good strengthened network because of more fraction of Q4SI is present. At the same time, what we have got from the Raman spectra,
Sultan,
that
please
actually,
conclude if.
yes sir, just 1 minute. Actually, the metaphosphate glass network is gradually converted to polyphosphate by the formation of Q1P and Q3P, and as the Q3P units are being formed, so PO bonds are stabilized. And at the same time, ALO4 and SiO4 is being employed in the network, so network dimensionality is also increased. Now, if we look at the thermal properties, from the first series to second series, it is improved, and with incorporation of silica, it is further increased. So, okay.
Now, what is your concluding statement?
Yeah.
Come to that conclusion.
Yeah, I will show you the. So, what we have explored in this study, that in case of commercial phosphate glasses, mostly the alumina are playing the modifier role, but in case of our second composition, it is playing as well modifier as well as former. So, due to this reason, it is strengthening the glass network. At the same time, incorporation of silica, it will increase the thermal conductivity and fracture toughness. At the same time, it will reduce the thermal expansion. So, it will improve the thermal loading capability. And this glass particular ABS2 B4, it has shown the good required properties which compared to most of the commercial laser glasses. So, thank you everyone.
Thank you, Sultan.
Yes, sir.
Nice work and good amount of work is done. So I hope there will be large number of questions, but only
Just
one
a
very
quick
big
question.
questions.
So your main target is to produce ND glass laser, or sorry, ETRBM glass laser for high power laser, right?
High
average power. So in that case, the facilities you show usually use ND glass, right? So what is you are reducing the thermo-optic coefficient? How much it has reduced? In comparison, that's all.
It is normally in case of commercial laser glasses, it is around 11 to 12.
Yeah.
12 into 10 power minus 6,
Yeah.
but we have achieved 6.4.
So almost half.
Yeah, almost half.
Nice.
Okay, so because of the time constraint, we have to conclude here. Thank you, Sultan, once again.
Thank you, sir.
So I'll request next speaker, Susmita Bera. So she will be talking on strategic modification of double perovskite bismuth WO6 with enhanced photocatalytic activity under visible light. So Susmita, again 8 plus 2.
Yes, sir. Okay. Myself Susmita, SRF of Energy Material Device Division. My topic is strategic modification of double perovskite bismuth tungsten oxide with enhanced photocatalytic activity under visible light. So these are the contents I will cover. Population growth and industrialization, use of fossil fuel increases global warming and various pollutions, and also that are affecting our ecosystem. That's why we are mainly focused to development of renewable energy sources. For that, we are mainly focused on solar energy because it is abundant to all and it has high energy density. Mainly in 2021, our Prime Minister, 15th August, our Prime Minister announced about green hydrogen mission. That is within 2050 make India as a hub for green hydrogen generation. Green hydrogen means hydrogen generation through a sustainable manner for which photocatalytic water splitting is an effective approach. Basically, this is an artificial photosynthesis where mainly semiconductors are used as photo-absorbing material. in presence of light, photogenerated electrons and holes are created. These electrons are transferred to the counter electrode site and which reduce the water molecule to generate hydrogen, and holes are diffused in the electrolyte to oxidize the water molecule. So these are the water oxidation reduction reaction. Here main problem is the electron hole recombination. Therefore our objective is to introduce double perovskite bismuth tungsten oxide as efficient photocatalyst, and to hinder the recombination problem we are trying to develop heterojunction with bismuth iron tungsten oxide and iron oxide, and we are also carried out the metal doping to reduce its band gap. So we choose bismuth tungsten oxide because of its n-type conductivity, moderate band gap and layer structure, chemically stable material. Main problem is narrow light absorption, low surface area and weak surface adsorption capacity. Therefore, we are trying to develop heterojunction with bismuth iron tungsten oxide because it has lower band gap 1.9 eV compared to this, and it has also multiple oxidation state, and it is also mainly n-type conductivity. Its problem is low surface area and fast electron hole recombination. Therefore, we are trying to develop heterojunction between this and this to hinder these problems and improve the catalytic activity. And further we are trying to develop doping at bismuth tungsten oxide to reduce the band gap, because doping may create extra electronic state near the valence band, conduction band as well as at the middle. So in first work we are trying to develop heterojunction between tungsten oxide and bismuth iron tungsten oxide, for which we followed two-step hydrothermal method, and we confirmed the heterojunction formation through XRD, where we got both the characteristic peaks of bismuth tungsten oxide and bismuth iron tungsten oxide. So further we studied the morphology through FESM and TEM, where we got very nice rose-like flower, assembled flower of bismuth tungsten oxide, and bismuth iron tungsten oxide shows nanoseeds kind of morphology which are connected each other, and interestingly when heterojunction formed, assembled structure has been obtained. And we also confirm the elements through mapping, and this TEM image and HRTEM image we tried to determine the growth direction as well as the crystallinity of the material, and after heterojunction both the cross pinches have been obtained, and both the characteristic peaks of tungsten oxide and bismuth iron tungsten oxide present, and we also compare the atomic percentage through the EDX experiment. So finally we study the XPS analysis to confirm the oxidation states of the elements, where bismuth remains in 3+ state, tungsten in 6+ state and iron in 3+ state. Interestingly, after heterojunction formation, the surface absorbed oxygen group enhances, which is the indicative of active surface enhancement of active surface area. So we finally studied the photocatalytic activity through photocatalytic hydrogen generation and photoelectrochemical water splitting. In hydrogen generation, we obtain 4 times higher hydrogen generation rate compared to bare materials, as well as in photoelectrochemical LSB linear sweep voltammetry we got very high current density, photocurrent density mainly. In presence of light we studied this experiment compared to the bare materials, and we also studied the photo sensitivity as well as photo bleaching effect through the chronoamperometry study, where heterojunction as developed heterojunction shows very high current density. And finally we also calculate the incident photon to current conversion efficiency of the bare materials as well as heterojunction, and we got maximum 32% efficiency at 450 nanometer. That is material is quite efficient in visible light absorption. And we finally studied Nyquist plot and Morsotky plot for the explore of the mechanism, and from the in Nyquist plot charge transfer resistance decreases after heterojunction formation, which is indicative of more facile charge transfer. And from the Morsotky plot we calculate the flat band potential of the bare material, and from that we calculate the conduction band and valence band potential, and we draw this energy diagram, and we are trying to propose mechanism of the heterojunction that is here NN as both of the material shows n-type conductivity, so one NN heterojunction may formed where electrons may vectorially transfer from conduction bond of bismuth tungsten oxide to conduction bond of bismuth iron tungsten oxide, and these electrons have sufficient reduction potential which are for the hydrogen generation, and at the same time we use methanol as scavenging agent which can quench the holes so that the system we may get more electrons in our system to reduce for the reduction reactions. So yes sir, so further we try to metal doping where we choose molybdenum, iron and zinc, and we through the hydrothermal method, and also we studied XPS to confirm the doping where characteristics peaks has been shifted, and these are the morphology, and as expected the band gap reduces after molybdenum, iron and zinc doping compared to bismuth tungsten oxide, and we further we confirmed the doping through XPS analysis where we got molybdenum the characteristics peaks, and we confirmed that molybdenum remains in 6+ state, that means it remains molybdenum partially doped at the tungsten side. Further we calculate the secondary electron cutoff and valence band XPS through which we draw the energy diagrams, and we also calculate the ionization potential as well as work function energy, and clearly work function energy of the after doping has been reduced as compared to bare bismuth tungsten oxide. So that is means doping effective not only effectively reduce the band gap but also it enhance its catalytic activity, and as expected we got highest result for molybdenum doping. That's why we are choosing molybdenum doped bismuth tungsten oxide, and to develop heterojunction with iron oxide we selectively choose iron oxide because of its suitable band structure, means conduction band and valence band. Here also we followed hydrothermal method, and this is the morphology, assembled kind structure have been formed, and we also confirmed the heterojunction formation through XRD analysis, and as expected here we got 8 times higher photocurrent density compared to the bismuth tungsten oxide and molybdenum doped tungsten oxide, and similar kind of result has been obtained at chronoamperometry. So finally we to get the mechanism and to understand why we got higher result in photoelectrochemical effect. So we studied the valence band XPS and secondary cutoff, and then validate this result through Morsotky analysis, and we calculate this parameter of ionization potential, work function energy, flat band potential and conduction band energy, through which we are trying to analyze what kind of electron hole transfer is going on in our system. Here these photogenerated electrons may vectorially transfer from this to this for the lower potential of this material iron oxide, and holes may transfer to this to this. Yes sir, this is concluding. And these therefore electrons and holes are separated in the both separated in both body. That's why these electrons may reduce the water to generate hydrogen, and holes can oxidize water to generate oxygen. So using this system we may get hydrogen as well as oxygen. That is, this material is suitable for overall water splitting. So these are the conclusion. Mainly we followed hydrothermal method to prepare flower kind of structure, and then we at first we trying to reduce its band gap, and then heterojunction formation to reduce the recombination rate. So I want to acknowledge Director Dr. Shravanti Ghosh and Rajendranath Basu as constant for their constant support as PhD supervisor, HOD and all members of my division EMDD, Professor S. Basu, Director CSIR IIMT for his collaborative work, and Professor V.R. Dhanak, University of Liverpool for his support during my stay at Liverpool, and instrumentation and characterization, finally Inspire Fellowship and Newton Bhabha visit for this short-term visit. And thank you all.
Thank you, Susmita. So, maximum 1 or 2 questions, if any.
Yes, it's a very nice presentation.
Thank you, sir.
So you are identifying Fe3 plus or molybdenum 6 plus only by XPS, or have you substantiated that with some other experiment?
No, sir, only by XPS.
But if you deconvolute this XPS spectra, so you will get, for example, molybdenum 6, you will get molybdenum 4, molybdenum 2, molybdenum 3, you will get everything.
Yes,
and
yes.
for Fe3, for
Yes.
example, Fe3 plus, you will always get Fe3 plus in the XPS spectra. So how can we only say that only Fe3 plus is there by XPS spectra? I think that is too simplistic.
Okay. So here you can see this is main characteristic speaks for tungsten 6, molybdenum 6 plus state, and we also get 2 peaks, which is indicative of oxidation state. But from XRD, we did not get any molybdenum oxide peaks. So it may remains in the surface of the material.
For identifying this state of molybdenum, there's only possible route is through synchrotron or something else. This XPS is very simplistic.
Okay.
Through XPS, you cannot say whether molybdenum is there only by 6 plus state or any other state.
Okay.
So it's very, I mean, you can say that, okay, probably if only 6 plus is there, but
Okay.
only 6 plus is there is too simplistic.
Okay. Okay, sir. I will.
Any more questions? Okay, I have one small question.
Yes, sir.
Like, you have shown that your new material is having much higher hydrogen generation
Yeah,
efficiency.
yes, sir.
Have you studied the cycle efficiency?
Yes, sir.
How
We
many
have
cycles
checked
you
up to
understand? What is the-
four cycles.
4
and
cycles
4
only?
cycles for hydrogen generation, and we got 13% loss.
Every cycles?
No, sir. After 4th cycle.
After 4 cycles?
Yes.
So,
Actually, during we studied the experiment, and then we collect the sample, dry it. Again, we are trying to we used that materials for second cycle, and during
since your new material is having enhanced hydrogen efficiency, you try to see what are the degradation criteria efficiency is coming down, because cyclic efficiency is most important.
Okay, sir.
Really application to go application.
Okay.
Anyway, thank you once again.
Thank you, sir.
So I will ask next speaker, Saurabh Das Chakraborty. So he will be speaking on high peak power ultra fast pulse through crypt pulse amplification, sorry.
Yeah. Yeah. So, can I start? Yeah. Hello everybody, my name is Saurabh Das Chaudhary. I'm a project scientist in fiber optics and photonics division. So today I will be talking about high peak power ultrafast pulses through chirp pulse amplification. So first, going into the actual work, I will show what is the ultrafast domain. Ultrafast domain is the picosecond and the femtosecond pulse durations, which is in seconds in 10 to the minus 12 to 10 to the minus 15. And depending on the pulse energy, all these applications can be accessed. So to achieve that, to achieve a high energy ultra short pulse, the method was first proposed in 1985 by Donna Strickland and Gerard Moreau, which won them the Physics Nobel in 2018. And this is their original paper where they proposed this configuration, and initially there is a seed oscillator which is producing ultrafast pulse but at a low energy. Then that pulse is stretched in time domain, so the pulse is broadened in time domain through a 1.4 kilometer single mode fiber, which is also called chirping of the pulse. And then this pulse, when the peak power goes down, pulse gets broadened in time, the peak power goes down, and they are amplified in an Indiglass regenerative amplifier. After amplification, this is the best novel part of this work, they recompress the pulse into ultrafast domain, and when they did that, as the pulse acquired more energy through this amplifier, the pulse peak power shoots up significantly. So this is chirp pulse amplification. This is mostly free space configuration apart from this fiber part. This is the chirp pulse amplifier that I have designed in the lab. So this is the seed. Here the first major difference is, apart from the compressor, final compressor, the entire design is all fiber. So it is giving you a alignment free configuration. It is all spliced. You can literally flip it and nothing will happen. So this is the seed oscillator. The seed oscillator produces a pulse in sub picosecond regime with a low energy. That pulse is amplified to a certain energy, small energy still, and then it is stretched in time domain using a normal dispersion fiber. Then this is amplified in a boosted amplifier, double cut high powered amplifier, and the pulse energy significantly shoots up. And then I decompress the pulse to achieve ultra fast pulse duration, which I will show. And the pulse energy here, due to this loss of this compressor system, I get higher energy from the oscillator to the final energy is significantly higher. So this is energy amplification to chirp pulse amplification. So this is the pulse spectra after the amplifier, pre-amplifier, and during stretching, due to non-linearities in the optical fiber, the spectrum also broadens. This is the output power curve and the spectral width, the increment of the spectral width and the increment of the output power. This is the stretched pulse. After stretching, I achieve a around 140 picosecond pulse. Then this 140 picosecond pulse is amplified in the next boosted amplifier. Here I achieve almost 3 watts of power, and this is the final spectrum. Now after compression, this 140 picosecond pulse comes down to a pulse width of only 263 femtoseconds. So there is a compression factor is almost 517 times. I am compressing it down to 517 times. And this is the comparison from seed to the final compressed pulse. So in the seed, the average power was only 15 milliwatt. Pre-amplifier, I amplified it to 90 milliwatts. Amplification, it goes to 3 watts. And then due to compressor loss, I get less power, but the final power is around 2 watt. Pulse energy goes up significantly. The major point is the pulse width. Pulse width goes into sub 300 femtoseconds. And the peak power goes from 1.2 kilowatt to sub megawatt. It goes into 418 kilowatts almost. So this is chirp pulse amplification. But before designing the amplifier, it is very important the seed characteristics, because ultimately I am amplifying the seed, and the seed characteristics finally decide what will be the final amplified pulse characteristics. So this is the seed oscillator. This is the mode locked seed oscillator, dispersion managed domain. This is mode locked using a CSAM, which is a semiconductor saturable absorber mirror. Then there is the gain medium, which is ytterbium doped fiber, and this ytterbium doped fiber is in-house fabricated in CSIR. And there is a chirp fiber bracketting. So this makes the oscillator and get mode locked pulse train out of it. And this produces pulse in sub-picosecond regime. And this is the pulse train. But what happens when I am increasing the seed oscillator power itself, pump power itself, I can see there is a change in the pulse spectrum. In frequency domain, the spectral shape changes from a near rectangular shape to a trapezoidal shape, and finally relapses into a triangular shape. When I study this, what is happening exactly during this transition, through a mechanism called a method called DFT, which is a very new method, popular method right now. What it does, I take a pulse, I put it through normal dispersion fiber. What normal dispersion does is stretches the pulse depending on its frequency content. So as it maps the frequency content to its time domain, I am virtually doing a Fourier transform. So this is, as I am using dispersion to do real-time Fourier transform, this is called dispersive Fourier transform method. And there is a whole computer algorithm to do this mapping from time domain to frequency domain. Through DFT, what I see that at low power, when the spectrum is actually rectangular, the real-time pulse spectrum is very stable. So this is a very round trip to round trip. These are like 2500 consecutive pulses I am seeing, and they are very stable. When I increase the power, the spectrum is unstable. It goes into an instability, and there are sporadic high intensity peaks. If I plot the wave intensity distribution of this particular unstable train, I see this kind of heavy tail distribution. This does not follow a Gaussian or Poisson or any standard distribution. This is called a heavy tail distribution. And in nonlinear pulse dynamics or even in fluid dynamics, this kind of heavy tail pulse wave amplitude distribution indicates there is existence of optical rogue waves. So this is the first time observation of optical rogue waves in a due to spectral filtering induced multipulsing instability, and this we reported in 2019 in optics letters. And right now what we are doing, as our compressor system is giving a bit of loss, we are not right now going into pulse compression, we are still trying to organize the compression system. We are now using the amplified pulse, which is around 140 picoseconds, to generate to produce nonlinear wavelength conversion in 14 crystal fibers, which is again in-house made by us. Then here this is the output spectrum after the 14 crystal fiber. So this is the pump wavelength at 164 nanometer, and I see first SRS peak, and then there is a significant broadband. The broadband is more than 400 nanometer broad, and this is in the NIR domain, and there is visible frequency up conversion through nonlinear processes which is seen outside the fiber tip. I can see blue light generation from photonic crystal fiber. So now we are trying to optimize this nonlinear wavelength conversion process, and also I am targeting a package fiber based CPA system for nonlinear wavelength conversion and for multiphoton microscopy. Multiphoton microscopy specifically requires very ultra short pulses with low energy but at particular wavelengths. If I can generate this kind of broadband pulses and I can use filters, I can take out individual wavelength spectrums which will be very narrow pulses, very narrow pulses, and I can generate, I can use them for multiphoton nonlinear microscopy. So yeah, thank you. That's
Good.
all. Questions?
It's a perfect timing. So, any questions? Have you fabricated any device out of it?
Planning any device? Yeah, we are trying to package it. So, see, this is the configuration, right? So, this is the schematic diagram. So, there is the seed of preamplifier, stretcher, final amplifier, and compressor. So, this is the real one, the real configuration. So, there is the seed, there is a preamp, this is the stretcher, this is the amplifier. We are already putting the amplifier in a box. So, make it compact, and with another box we can package all of this. Why this requires a separate box? Because this is significantly higher power. So, its control electronics, pump electronics is bulky. So, it will be in a box, and rest of the system will be in another box, and we are targeting a package system which can specifically be used for these two applications right now. Because we are limited in energy, we have plans to go for higher energies also.
So, it's going to be application from our in-house development.
Yeah, in-house development. Yeah, fibers, all the gain fibers are in-house fabricated, and also the PCB is in-house fabricated.
So, very good. So, from audience, any questions? Since there is no question, so thank you once again. So, I'll invite next speaker, Sanjukta Rai. She will be talking on study on development of ceramic polymer composites, nanofiltration, membrane for removal of ionic contaminants from the aqueous solution.
Good afternoon, everyone. I am Sanjukta Roy from Membrane and Separation Technology Division. Oh, full screen, right? এটাকে খুলে যাচ্ছে? Yeah. Today, I am here to provide a very short overview on study on development of ceramic polymer composite nanofiltration membranes for removal of toxic contaminants from aqueous solution. So to start with, what are membranes? As we all know here, that membranes are semi-permeable barriers which permit the passage of certain components and selectively retains others of a mixture. So membranes can be of two types, that is inorganic, that is ceramic or zeolitic, and organic, that are polymeric membranes. Now coming to ceramic polymer composite membranes, they can be broadly classified or categorized into three types, where the first type is the nanocomposite membranes, where ceramic nanoparticles are embedded in polymer matrix. They are also called mixed matrix type membranes. The second type is the thin film nanocomposite membranes, where ceramic nanoparticles are present or dispersed in the thin film active layer of the membrane. And the third type is the ceramic supported polymeric composite membrane, where the active layer is polymeric material, and it is then the substrate is the robust ceramic substrate. So in the present work, we are going to focus on this third type of the composite membrane, that is the ceramic supported polymeric composite membrane. Now, why ceramic supported polymeric composite membranes? Ceramic supported polymeric composite membranes tend to combine the advantages of both ceramic and polymeric materials. To be precise, the advantages of both ceramic membranes and polymeric membranes. Ceramic membranes have the advantages of high mechanical, thermal and chemical stability, along with the advantage of being fabricating in a tubular module. And the advantages of the polymeric functionally is that it can be precisely tuned into the dense or microporous range, and the functionality of the polymeric active layer can be tuned according to the application. And also the cost of fabrication of polymeric active layer is much lower than pristine ceramic ones. Actually, ceramic NF membranes or microporous ceramic membranes are much costlier, though they are very few are available commercially. They are much costlier due to the cumbersome preparation technique. It needs several coating sintering cycles to precisely tune the pore size to the microporous range, and also the chances of formation of defects are large. So ceramic supported polymeric composite membranes provide the advantages of a robust ceramic substrate along with a facile and precise tuning of the polymeric active layer. So application of CSP composite membranes, the application of CSP composite membranes have been studied in various advanced membrane based processes like pervaporation and membrane distillation, but has much less been explored in pressure driven filtration processes, mainly due to the various challenges that are associated with it, that is the attachment of the ceramic and polymeric counterparts and complex preparation techniques. So CSP composite membranes can be fabricated in these various techniques like grafting, coating, layer by layer deposition, interfacial polymerization and atomic layer deposition. These are the various techniques which are involved in preparation of CSP composite membranes, but some techniques like atomic layer deposition are very costly, and grafting sometimes requires very complicated atmosphere like inert atmosphere, globe box, etc. So the background research study states that CSP composite membranes have been widely explored in pervaporation and membrane distillation applications. These two membrane-based applications require high temperature operation, like in 70-80 degree, maybe 90 degree temperature. And these, in case of pervaporation membranes, what is required is hydrophobic and dense layer. So this hydrophobic dense layer is prepared by the fabrication of a polymeric active layer over a dense, over a porous ceramic substrate. The porous ceramic substrate provides the high temperature stability. And in case of membrane distillation, there is a porous hydrophobic layer that is needed, and this hydrophobicity is provided by the polymeric grafting or polymeric coating. So these these two processes have wide application in like dehydration of organic solvents, biofuel recovery from fermenter, desalination, wastewater treatment, separation of volatile compounds, and concentration of non-volatile compounds. So those CSP membranes, CSP composite membranes have been applied in pressure-driven filtration processes. Their application is limited till date. However, they include oil-water separation, some heavy metal removal by polymer-enhanced ultrafiltration, and dye removal, complex industrial wastewater treatment, desalination, and most importantly, this category of CSP composite membranes have recently been studied in organic solvent nanofiltration. Now coming to nanofiltration, nanofiltration is a pressure-driven filtration, nanofiltration is a pressure-driven filtration technique which lies between reverse osmosis and ultrafiltration. So the pore size of nanofiltration membranes are typically in the range of 0.5 to 2 nanometer, and the size of particles that they are able to reject or remove typically lies between 200 to 2000 Dalton. But the removal mechanism in nanofiltration processes are much complex than in case of reverse osmosis, because in case of reverse osmosis the pore size is much lower.
2 minutes.
Oh, okay, sir. Okay, sir. Is lower, and the main removal mechanism here is size exclusion. But in case of nanofiltration, there are several factors that are aiding in removal, that is size sieving, donor or charge exclusion, steric hindrance, dielectric effect, and the transport mechanism of the solutes, that is convection or diffusion. So nanofiltration membrane has a typical behavior.
You come to your own work directly.
Sir, it is more of a general overview. I'm just...
Then you conclude it, what you got.
Okay, sir. Okay, sir. Then actually, nanofiltration membranes are give high rejection of divalent ions and low rejection of monovalent ions. And what we have done here is we have prepared a CSP composite membrane by augmenting the macroporous ceramic support by formation of two ceramic intermediate layers. One is of alpha alumina followed by gamma alumina. So that we have actually modified this macroporous support by two ceramic intermediate layers to get a requisite functionality and pore size and roughness for fabrication of a thin polymeric functional layer. And this polymeric functional layer is formed by using a glutyraldehyde as cross-linker and polyethylene as the polymer functional layer material. And this is the membrane surface, is FECM, where we can see a smooth and defect-free top layer. This is the probable cross-linking mechanism. So this CSP composite membrane was modified by two techniques, that is via dynamic membrane layer fabrication with EDTA and also by surface ionization with copper. In both the modifications, we get that from the compared to the pristine membranes, we have favorable rejection and flux properties by both modifications, and the pore size is getting reduced.
Make your conclusion.
Okay, sir. Okay, sir. Sir, we could get a good rejection of both cation and anionic heavy metals by the EDTA modified membrane, where we, there are several rejection removal mechanisms involved at different pHs, and the copper ion modified membrane also gives appreciable rejection of both anionic and cationic heavy metals. And these membranes can find practical application in removal of heavy metals from contaminated water. Indian rivers are contaminated with heavy metals, as can be seen from the report of the Ministry of Jal Shakti, and the levels of contamination are above, it crosses the BIS standard. And also we could see that several habitations in India are contaminated with heavy metals, and we need to treat those. Okay, thank you. I'd like to thank Director CGCRI, HOD MSTD, my supervisor Dr. Priyanka Mondal, my co-supervisor Dr. Ganesh Chandra Shahu, and each and everyone of MSTD for their kind support. Thank you.
Okay, thank you. Sanjukta?
Yes, sir.
So, one or two questions maximum.
Sanjukta,
Yes,
you
sir.
have prepared EDTA modified membrane.
Yes, sir.
So, how do you prepare that?
Sir, it is by a dynamic membrane layer formation approach, that is by cross-filtering EDTA at 8 bar pressure through the membrane.
So, EDTA is adhered on the surface.
No, sir, not only in the surface but also in the pore walls, since we are cross-filtering the EDTA.
So, after
through
that you have sintered the
No,
material?
sir, it's not. It is attachment with the polymeric layer of polyethylene,
Okay.
so no question of sintering.
Thank you. Thank you.
Okay, sir.
Sanjukta, first of all, it is a very nice presentation. Just I
Yes,
wanted to ask a very fundamental question, not as a question, so rather I can ask your opinion. You are basically making a composites of the ceramic to that of the polymer, right?
Yes, sir.
So ceramic supported polymer, if then the utility of using the ceramic support, how does it stand for in temperature, in terms of the temperature of the applications, or the corrosion resistance or the erosion resistance if you put a polymer coating onto the ceramic substrate?
Sir, actually, here I have shown it's the cross-linked polyethylene is very acid stable.
Yes.
But, sir, actually, in most of the polymeric membranes, commercial polymeric membranes, the basic substrate is a non-woven matrix. Mainly, and after that, polysulfone or something is coated, and after we get a polymeric functional layer. They are also asymmetric types, but the non-woven matrix, the cloth-like basic support that provides the mechanical strength to polymeric membranes, are in most cases not resistant to harsh environment. So ceramic
For the core itself you are talking about.
For the
core itself.
for
Core means inside,
yeah,
right?
Yeah, the substrate that provides the mechanical support in case of polymeric membranes are not of good quality. So we can, from that aspect, we can compare it with the polymeric. We are changing the ceramic
my
substrate.
questions.
And also, sir, from the ceramic point of view, pure ceramics NF membranes are very much costlier. So,
That is
if
so you want to make a techno-commercial viability
Yes, sir.
by making a composites of this
with
polymer
composites.
coated
Yes,
ceramic
sir.
substrate.
Sir,
right?
actually these when fabricated in tubular module, maybe we'll be able to backwash it because this ceramic substrate will provide high mechanical strength
I understand.
for all the purpose.
Thank you. Thank you.
Okay.
So I have one small queries. What is your application temperature? It goes here.
Oh, what is the application? Oh, sir.
Target application temperature where you are this kind of
Target
membrane will be.
application temperature, sir. Actually, since we are using in heavy metal, we can use for high temperature application,
What is
but
the
that will be for higher range of heavy metals in industrial scale. But since we have till now studied in a very we have simulated groundwater and surface water, that type of ranges. So till now it's room
What
temperature.
is the temperature range? Say 80
Temperature
degree or 200 degree or something?
No, sir. Till now it's at room temperature. Room
So
temperature.
that means this membrane can be used only for room temperature? Or it can
Because, sir, we haven't done a thorough temperature study, so till now we can't tell that it can resist temperature, but we
depends on your nature of polymers, what you are using.
Yes, sir. No, sir, this type of polymers are suitable for 40-50 degree.
40-50 degree only. Okay, anyway, thank you so much. So I'll invite next speaker, Anustup Chakraborty. So he will be talking on borosilicate, bioactive glasses, high temperature processability, in vitro biological properties, and composition structure property relations. So Anustup, you try to finish in 8 minutes.
Okay.
You come to direct your main work instead of wasting too much time in the introduction.
Good afternoon all. I am Anustup Chakraborty and I am going to talk on borosilicate bioactive glasses. So if you look at the early biomaterials before 1970s, they were mostly bio-inert and they were meant to provide mechanical support to the amputated limbs or so. But the problem was that body used to encapsulate those materials inside a fibrous tissue so that it can isolate those materials from other bodily interactions. Now in order to address that problem, bioactive materials came into the picture and Larry Henge was the guy who developed the first kind of bioactive material, which was a bioactive glass. And the main property of these materials are they can bond with the host tissue. This is a special property. And these materials are class A type materials, means it can provide support of bone growth on their surface as well as they can stimulate new bone growth. Now if you look at the mechanism of bioactivity, it happens through 5 stages. It ultimately leads to the formation of a hydroxycarbonate apatite layer, which is the mineral composition of our bone, and it leads to the formation of a bone bond with the host tissue. Now these are the common bioactive glass compositions. You can see mainly based on silicate system. Silica is the major network former here, and the one important parameter is network connectivity. It means like how many numbers of bridging oxygen atoms per network former units. So if it is less, that means the network is more weak and water can easily attack the network and it will show high bioactivity or faster bioactivity. These are the several products developed out of bioactive glasses. And out of these products, I want to focus on scaffold. This is an advanced material product, but there are some difficulties associated with processing these products. So primarily, I will tell about scaffold. Scaffold is a temporary framework and guide for the cells that regenerate bone. And these scaffolds actually mimic the cancellous bone structure. So through the pores of this scaffold, cells can easily migrate, and it provides sufficient pathways for vascularization so that new blood vessels can form through these pores, and it will lead to the faster bone growth. As well as it can be used for treating osteomyelitis disease, which is a bone infection, and it can be cured by using these scaffolds. I'll show how. So these are the major limitations of bioactive glasses. The major limitation is the main limitation is the crystallization tendency. So whenever we are trying to prepare a scaffold or draw a fiber, there is a sintering step or drawing step involved, which happens at a much higher temperature than the TG. So whenever we go above TG, this glass will rapidly crystallize, and that will affect the sintering process, and that will affect the fiber drawing process as well as the bioactivity, because crystal phase is not easily dissolvable as the glassy phase. Now this is a factor which determines the thermal stability of the glasses or the crystallization tendency of the glasses. If this Tx minus Tg difference is larger, then we have more freedom to work with these glasses at higher temperatures. These are some common glasses. Their delta T value you can see 45 S5 and S53 P4. These are commercial compositions, and their delta T value is very less, 88 or 103 degree. And they have the crystallization tendency. So on this we have done extensive literature survey, and we have seen that B2O3 incorporation is an effective strategy to improve their thermostability while maintaining their fast bioactivity. So based on these background studies, we have arrived at our objective, which is to propose an optimized glass composition with a suitable combination of surface apatite formability, thermostability, and antibacterial properties. Now in order to achieve that, we have prepared some glasses, 8 glasses. Out of that, base glass was purely silicate glass. And this glass was quite similar in nature with the S53P4 composition, but the major difference lies in their Na2:CO ratio, which is kept 1 here. And from the base glass, the SiO2 content was gradually replaced by B2O3. And you can see the 25, 75, Bg25, these numbers indicate that 25% of the SiO2 content is replaced by B2O3. And we have explored the 25 to 75% range because there are some literature reports earlier. So based on that, we have selected this range. And the glasses are prepared through conventional melt quenching technique. We all know about that. If we look at the properties now, the physical properties, XRD confirms all the glasses were amorphous in nature. And the density and molar volume profile indicates that glass structure gradually becomes more open in nature with B2O3 substitution. That has some major implications on other properties I'll show later. And any properties of a material can be explained based on their structure. So in order to do so, we have done structural studies through Raman spectroscopy as well as solid NMR spectroscopy, solid state NMR spectroscopy. Now from Raman spectroscopy, we can confirm that phosphorus units are predominantly present as orthophosphate units where there are no bridging oxygen atoms. But silicate units, there are 3 types. One is Q1, Q2, Q3. These numbers indicate their number of bridging oxygen atoms. And for boron units, we can see there are triborate units present, which is not so common for borate glasses. They are mainly boroxyl units are present, but here in a boroxyl ring, one BO3 unit is replaced by one BO4 group, and it forms the triborate unit. And we also can see for Bg50 and above, B2O3 composition, when B2O3 is more than 50%, that time you can see the presence of QP1 units, which is a pyrophosphate units, where one bridging oxygen atom is involved. And we can also see the formation of BOSI bonds. So now we'll go to the solid state NMR study. For 11Bu nuclei, we can see there are 2 major type of structural groups present. One is BO3 and one is BO4, indicated here as B3 and B4. Now this B3 also are of 2 types. One is B3 ring type, one is non-ring type. Ring type means the triborate units I have shown. You can see a network fragment here. So this ring type BO3 unit, it means that it is in a ring-like conformation. And but this is not a purely BO3 ring. There is a BO4 unit involved. That's why it is a triborate unit. And for non-ring type, those are not associated with any ring-like structure. And this eta Q, this is asymmetry parameter. This is a deconvolution parameter, fitting parameter we have obtained by deconvoluting this spectra. This indicates that BO3 non-ring units are only having non-bridging oxygen atoms, and that is only 1, not more than 1. Where ring type are not having any non-bridging oxygen atoms associated with them. And BO4 units, they are of 2 types as mentioned here, BO41 and BO42. So these 2 types means one type is having 2 silicate neighbor and 2 borate neighbor, whereas the other type has 3 silicate neighbors and 1 borate neighbor. So we can see that these borate and silicate structural units are highly cross-linked because there are interconnection between these two types of structural groups. And we also see that this network is highly polymerized. Why I am telling so? Because we can see the BO4 units and BO3 ring type units, they constitute the major portion of the borate network, 80% almost. So it is a highly, and they don't get associated with any non-bridging oxygen atoms. That's why I tell this borate network is highly polymerized when B2O3 is increased. And if we look at the sodium and phosphorus NMR study, we see the sodium NaO bond length is increasing as indicated by the delta ESO value. It means it is taking the charge compensator role for BO4 units. And we can see the presence of mainly orthophosphate units, but beyond BG58, there is a slight presence of pyrophosphate units, as I have told from Raman also. Now we have performed DSC analysis for all the glass compositions, and from DSC I have identified the TP, that is crystallization peak temperature, and at that temperature we have heat treated the samples to identify the crystalline phases. And we can see the delta T value is highest, from the table we can see the delta T value is highest for BG42, and this delta T is a function of TG and TX both. So if we understand the changes in TG and TX, we will understand the changes in delta T. So I am not going in detail here, but the highest thermal stability is obtained for BG42 composition, that is 180 degrees centigrade. Now we have done in vitro bioactivity study, which means how fast it forms the apatite layer on its surface when we study inside a simulated body fluid in the laboratory environment. We see upon 1-day immersion, we see the formation of apatite layer from XRD, but XRD cannot confirm it is a carbonated or only apatite, so FTR confirms it is a carbonated apatite. Now FESM also confirms the formation of apatite layer on the surface. This in vitro dissolution behavior was done on the collected fluid solutions after the typical immersion periods, and the dissolution rate increases with BTO3 substitution, which is due to the formation of BOSI and BOB bonds. In vitro cell proliferation study was also performed. We can see the cell proliferation rate increases with BTO3 incorporation, but beyond 33% BTO3 substitution, there is a slight decrease, although it is not so high. The increase is not so much because all the glasses are showing quite higher cell proliferation percentage compared to the base glass, not the base glass, a controlled TCPS, tissue culture polystyrene. And the increase is attributed to the released Si4+ ions and alkaline pH environment, while that little bit decrease beyond 33% is due to the presence of borate ions. Now ALP activity was assessed for the optimized composition, which is the BG42 composition, and there we can see the ALP activity improved even from the osteogenic supplemented TCPS. So it shows clearly that BG42 glass stimulates osteogenic differentiation. And if we have assessed the antibacterial property also, we have seen with borate ions, with the increase in BTO3 content, the glasses show increasingly higher antibacterial property, and these glasses have quite well antibacterial property against E. coli bacteria, which is a gram-negative bacteria and quite often involved with osteomyelitis disease. Now, in summary, we have developed some thermally stable composition, and the highest was for BG42 glass, and the devitrification tendency or crystallization tendency was related to the combite or sodium-calcium silicate and calcium-sodium borate phases. All the glasses exhibited promising in vitro bioactivity, that is within 1 day, which is only obtained for 45S5 composition. But it is having very low thermal stability. We have higher thermal stability and better cell proliferation percentage for all the glasses, while elevated LP activity is evidenced for BG42 glass. Antibacterial activity was quite well for all the glasses. And if we look at the future directions, we have already made some scaffolds out of this glass for optimized glass, and we have done so through the foam replication technique, where the foam was dipped inside a glass slurry and it was heat treated, so the foam burns out and we get a glass scaffold. It was made, but some optimization is still required. We are doing so. And I want to acknowledge all these people. Thank you for your help and support, and thank you.
Thank you, Anushka. Maybe 1 or 2 questions from audience.
Hello. Anushtup, that is a very nice presentation. I have a query just, that how do you confirm that all the borate units that are in, no non-bridging sites are there, all are bridging sites?
I told non-bridging oxygens are there for non-ring BO3 units.
Okay, only for ring BO3 units?
If I show you, actually that is deduced from the eta Q parameter, that is the asymmetry parameter. From literature, you can already find that these parameters are associated with the number of non-bridging oxygen atoms associated with the different units. So if it is 0.85, that means there is one non-bridging oxygen atom associated. It 0.2 means there is none. So like that.
Thank you, thank you.
Anushtup, you have taken these boron compositions like B2O3 and silica gas compositions, but it is not quite obvious that if you take eutectic compositions of the silicon boron phase diagram, and at the eutectic compositions your viscosity will be much lower, and that's why you are getting the higher TG. Simple as that.
I'm not getting a higher TG.
Not higher TG, the delta TA.
At the eutectic composition you
Yeah,
have.
because you have taken silicon boron. If you see, there is a eutectic point.
But I don't think eutectic composition will give higher delta T.
Yeah, because no, if you have eutectic compositions at that range, the viscosity will be lowest. And whenever there will be the viscosity will be the lowest, there will be no crystallization. That's why you are not getting
No,
crystallization.
sir, I want to make a point here. Actually, viscosity will be lowest, but this low viscosity will allow to crystallize also too rapidly. Crystallization will also happen rapidly due to that, because there will be more mobility inside the structure. They can easily reorganize into crystal structure. So it is a function of both Tx and Tg. Only Tg we cannot look at. Tx will also be lower, so difference won't be higher. That is my understanding as of now.
Okay, Anushtup, I have one small
Yes.
doubts. Like once you're increasing the boron content, your antibacterial properties also keep on increasing. Is it due to your boron like structures where BO4 units or BO3 units increasing, that ratio change? Is it
Actually,
because of or some other else?
it is actually because of the presence of borate ions, because all other things are constant. So only the change in the B2O3 concentration. And we can see the ion release profile. There also B3 plus ion release is much higher for high B2O3 containing classes. And these borate ions have, from literature we can see, these have some evidently higher bactericidal effect. Even boric acid is used for healing the cuts and wounds. So due to the, what you are telling about the structure, so the structure helps in faster release of these ions. So when BOB bonds are increasingly forming or BSI bonds are increasingly forming, they will help to release these ions faster.
Excess B2O3 enter into the systems, it forms the more BO4 units.
Yes, no. The BO4 units are always 60% from the beginning, but it is little bit decreasing up to 55% when it is going to 75% substitution. It is not, but predominantly there are BO4 units. But the dissolution behavior we have found that it is not linked to the only BO4 or BO3 units, it is linked to the bonds, because water can easily attack those bonds.
My point is how the antibacterial activity increases.
Antibacterial,
the boron.
antibacterial activity is primarily increasing due to the borate ions, but the borate ion release is increasing due to the structure.
Okay.
The structure is helping to release those ions.
Okay.
Anushtup.
Thank you, Anushtup.
Thank you.
So, with this, we have come into the end of the session. Yes.
Thank you very much, sir, for charging this session. On the behalf of Gramix Fiesta team, I am honored to present a memento to our session chair.
Oh my God.
Okay, this is now the end of this session, and we will go for tea now. And after the tea break, we will reassemble here at 4:30 p.m. for the cultural event. And thank you very much. One little announcement that we will have a closing session on Monday, 13th June, 3 to 5 p.m. Kindly attend, please. Okay. Okay, sir. Okay. Yes, of course, this is for everyone and all the participants and also the coordinators and the group members. Thank you. Thank you.
হ্যালো 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 ল্যাপটপের সাউন্ডটা লাগবে সব সময়ের জন্য অন করে রাখো ল্যাপটপের সাউন্ডটা সব সময়ের জন্য অন করে দাও হুম 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 কোনটাতে না বলছি কালকের যে সেটিংটা করেছিলে না দাদা কালকে যে সেটিংটা করেছিলে ওরকম সেটিং রেখে দাও না চেক আমি তাহলে সেই সেটিংটা করে এখানে সাউন্ড কম বেশি করতে হয় আপনার একটা এখানে পার্মানেন্ট করে দিন একটা সাউন্ড না না আমি ল্যাপটপের সাউন্ডের কথা বলছি পার্টিকুলারলি সময় পাবো না আসছে টেস্ট করতে আসছে টেস্ট এটা কি হবে
ঢোকাবো পেন ড্রাইভটা কোথায় ঢোকাবো এসকেপ করবো এ কি ইয়ে চলছে মানে লাইভ চলছে না এটা আমি তো টেস্ট করতাম পিপিটিটা আমি তো এটা তোমার রিসাইটেশনটা দিচ্ছি না না মানে রিসাইটেশনটা দিচ্ছি পিপিটিটা প্রথমে বোধহয় ইয়ে হবে ইনাগুরেশনের পরে রিসাইটেশন হবে তারপরে নাচ হবে এটা একটু অফ করা যাবে প্রজেক্টটা একটু অফ করে দাও লাভ অফ করছে হোস্ট করছে ওই অনিশা নির্মাণ না অনিশাতেই আর কে করছে আমি জানি এইটা একটু অফ করে দাও স্ক্রিনটা বেরিয়ে যাবো এই হলো গো প্রজেক্টটা থ্যাংক ইউ হ্যাঁ এইটুকুই করতে হবে এর থেকে বেশি না আমি কিচ্ছু করতে হবে না রিসাইটেশন তো আমি করব না আমি তো দেখে দেখে বলবো এই আবার তোমার চেয়ে হচ্ছে না আসছে না গো পেন ড্রাইভটা তোমার কেন হয় না আমি জানি
আরে ওই সেদিনে কালকের কার্তিকার ওই পেন ড্রাইভটা লাগানোর পর থেকে অনেক পেন ড্রাইভই এরকম বলবান ওর মনে পেন ড্রাইভে ভাইরাস ছিল
অন্য কোনো পয়েন্টে ঢোকানো যাবে
তাড়াতাড়ি কপিটা করে নে
কোথায় যেন রাখছি এখানে না ডে 2
ঘর থেকে পালাতে হবে
देखो तुम्हारे पास दो ही ऑप्शन है, या तो मैं तुम्हारे पास दो ही ऑप्शन है। देखो तुम्हारे पास दो ही ऑप्शन है, या तो मैं तुम्हारे पास दो ही ऑप्शन है, या तो मैं तुम्हारे पास दो ही
Your paper got rejected. You may leave now. Your paper got rejected. You may leave now.
28 साल का लड़की हो गई तो कब शादी करना है तुझे? कब शादी करना है
आजकल
तुझे?
का लड़कियों को देखो, कपड़ा पहनने का तमीज ही नहीं है। कपड़ा पहनने का तमीज ही नहीं है। कपड़ा पहनने का तमीज ही
Your
नहीं
paper
है।
got rejected. You may leave now. Your paper got rejected. You may leave now.
आजकल का लड़कियों को देखो, कपड़ा पहनने का तमीज ही नहीं है। कपड़ा पहनने का तमीज ही नहीं है।
देखो तुम्हारे पास दो ही ऑप्शन है, या तो मैं तुम्हारे पास दो ही ऑप्शन है, या तो मैं तुम्हारे पास दो ही
Your paper got rejected. You
Thank you.